Sir, shall I start?
You can start now, sir. You
Yeah.
can start, sir. Yeah. Please take
So-
notes. See.
Expert from Gyan course, Dr. Sharma, and dear participants. This Gyan course is designed on water sensitive urban design and integrated urban water management. You may be aware that Ministry of Jal Shakti is putting a lot of efforts for water conservation. In my second lecture, I'm going to give you highlights of what are the efforts of Government of India as far as the integrated urban water management is concerned, apart from that of groundwater management, rural water management, and urban water management. This specific lecture I have prepared for urban ponds. Basically, principles to practice, nothing new to you. Let me tell you on the very first slide, whatever I am going to show you. Am I audible, sir?
Yes, sir.
Yes. So nothing is new to you. You all already know my presentation. But as an engineer, as a practitioner, what are the ways, what are the means by which we can improve it? Or in future, if you are planning or regenerating urban ponds in India, let me inform you, lot of regeneration work is going on of water bodies. River regenerations, crores of rupees has been pumped into it. Urban ponds, again, crores of rupees is pumped into it. That what has happened, I'll just show you after 2 or 3 slides. What has happened in India as far as the water resources are concerned, and why Ministry of Jal Shakti has been framed, and on their agendas, the topmost priority is given to water conservation. Let us first talk about urban ponds. So as we know, what is water conservation? So you can cite this article. This will be with you. Recording will also be with you. This is the, what we can say. You can cite this article whenever you wanted to use it in your future research work or consultancy work. The content of my today's presentation is what we will talk about water conservation. Then we will talk about percolation ponds. When we talk about percolation pond, we will talk about design aspects of percolation pond, site selection criteria of percolation pond, investigation required for percolation pond, engineering aspects of pond, design criteria for various ponds. Finally, we will see the practices, that is urban ponds, how they are managed, how they are managed, how they are regenerated in India. So all are aware with the term water conservation, which refers to the prevention, control, and development of water resources, both surface and groundwater, and prevention of pollution. Percolation tanks are among the most common runoff harvesting structures in India. Urban ponds are one of the essential natural elements that have supported urban communities with ecological benefits as well as socio-cultural and economic activities. These ponds are presently facing extinct threats due to increased urbanization and lack of available space in the cities. Let us talk about the percolation ponds. They may be provided with arrangements for spilling away the surplus water that may enter the tank so as to avoid overtopping of the tank bund. The hydrogeological conditions of site for percolation tank is very important. If there are rocks, these rocks should have high permeability. The degree and extent of weathering of rocks, that should be uniform, not just localized. The purpose of percolation tank is to conserve the surface runoff and diverts the maximum possible surface water to the groundwater storage. The water accumulated in the tank after monsoon should percolate at the earliest. Sir, in India, as you are aware that we have rain almost on 2/3 part of our country during monsoon season only. That is July, August, September and October. And rest of the 8 months, 2/3 part of the India is not receiving any rainfall. A percolation tank is designed to ensure maximum capacity utilization, long lifespan, cost effectiveness, and optimum recharge to groundwater. Storage capacity, waste wear, drainage arrangement, and cutoff trench are the important features of percolation tank which need proper design. The overall design of the percolation tank is similar to a small earthen dam without canals. That is small minor irrigation scheme without irrigation canal. There are the most prevalent structures in India. They can be constructed both in alluvial as well as hard rock formation. The efficacy and feasibility of this structure is more in hard rock formation where the rocks are highly fractured and weathered. In the states of Maharashtra, Andhra Pradesh, Madhya Pradesh, Karnataka and Gujarat, the percolation tanks have been constructed in plenty in basaltic lava flows and crystalline rocks. Percolation tanks are to be normally constructed on second or third order streams as the catchment area of such streams would be of optimum size. The location of tank and its submergence area should be in non-cultivable land and in natural depressions requiring less land acquisition. Steps should be taken to prevent severe soil erosion through appropriate soil conservation measures in the catchment. This will keep the tank free from siltation, which otherwise reduces the percolation efficiency and life of the structure. The catchment yield and basin configuration drawn from topographic surveys at site determine the height of the percolation tank. Now, one by one, we will see the various aspects of percolation tank. Number one, site selection criteria. The area's hydrogeology should be such that the litho units that exist in the pond submergence area should be highly permeable. Soils in the tank's catchment area should be sandy to prevent the tank bottom from silting up. There should be ample availability of non-committed surplus monsoon runoff to ensure that the pond is filled every year. Choosing a percolation tank's volume should be controlled by the strata's percolation potential rather than the catchment yield. In order to avoid water wastage by evaporation, large capacity tanks should only be installed if the percolation capacity is known to be sufficient. If percolation rates are low to medium, smaller capacity tanks may be installed. The percolation tanks are usually designed for 0.1 to 0.5 million cubic meter storage capacity. The depth of water impounded in the tank provides the recharge head, and therefore the tank must be built to provide a minimum height of 3 to 4.5 meter ponded water column and rarely 6 meter above the bed level. So usually the tanks are provided with 3 to 4.5 meter ponded water column in India. This would involve the construction of large capacity tanks in areas with a steep gradient. The percolation tank should be situated downstream of the runoff zone, ideally towards the edge of the pediment zone or in the upper part of the transition zone. Land slopes between 3 to 5% are suitable for the construction of percolation tanks. Investigation criteria. When you have decided that at this location you wanted to go for construction of a pond, what are the criteria which are required to be investigated? The entire watershed needing additional groundwater recharge is identified on the basis of declining water level trends both during pre and post monsoon, increase in the demand for groundwater and water scarcity during lean period. For artificial recharge, areas with water scarcity during the summer despite flood incidences during monsoon may also be considered for selecting the site for the percolation tanks. A detailed map. So what are the requirements for selecting the site for percolation tank? Detailed map, ideally at a scale of 1:50,000, showing all available geographical, physiographical, hydrogeological, and hydrological data along with land usage, crop pattern, etc. is a requirement for scientific planning. Survey of India toposets, aerial photographs, and nowadays even drone surveys and satellite imagery of the area may be consulted to gather preliminary information about the area under study. To determine their impact on runoff, the nature of catchment in terms of general slope, land use, forest cover, plant pattern, soil geology, etc. should be understood. During the preliminary investigations of precipitation, data will be obtained from rain gauge stations located in the watershed or in its immediate vicinity. It is necessary to analyze the intensity and pattern of rainfall, the number of rainy days, and the duration of dry spells during the monsoon season. In addition to other weather variables, the intensity of normal monsoon rainfall and the departure of actual rainfall from normal rainfall are also being worked out. Percolation tanks should normally be constructed on second or third order streams. The tank's location and submergence area should be situated in non-cultivable land and in natural depressions requiring less land acquisition. With a number of wells, cultivable land should be available downstream of the tank in its command to ensure maximum benefit from such efforts. In order to determine the permeability of the Meadows zone and aquifer, detailed geological and hydrogeological mapping shall be carried out in the submergence area at the tank site and also downstream of the site. Based on the aquifer structure, the potential for additional storage and the aquifer's ability to transfer groundwater in adjacent area is also required to be measured. The type of soil are to be determined through infiltration test in the probable area of submergence. It is also possible to determine aquifer parameters of water-bearing formation in the zone of influence to assess the potential for recharge and the number of feasible groundwater structures in the area. Periodic water level measurements can be performed before and after the installation of percolation tanks along with groundwater testing for water quality. Detailed geological studies may be undertaken to study the existence and depth of formation at the burnt site to determine the correct cutoff trench depth to avoid the seepage from the tank. This will help to reduce visible seepage and also ensure the structure security and long life. The depth of foundation and its treatment should be considered in the design and construction of the dam wall and west weir on the basis of the nature of the formation. What are the engineering aspects one should keep in mind while going for a percolation tank? A percolation tank is an earthen structure with a masonry or concrete spillway. It should be designed with maximum capacity utilization, cost effectiveness, long lifespan, and optimum recharging of groundwater in mind. Storage capacity, west weir, drainage arrangements, and cutoff trench are the key features of the percolation tank that require proper design. The percolation tank's overall design is similar to an earthen dam built for minor irrigation scheme. Several sections are prepared along and across the drainage, identifying the best suitable site. During the survey, land availability and land acquisition possibilities are required to be explored. The site is demarcated and designed to allow the flow of surplus water based on a single day maximum rainfall after the maximum capacity of the tank is reached. Depending on the nature of the formation, the depth of the foundation for the masonry or concrete work of the west weir, etc. be decided. To minimize the seepage losses across the stream bed, a cutoff trench is required to be provided. Depending on the subsurface strata, the COT depth is generally 2 to 6 meter below ground level. The stone pitching is provided in the upstream direction up to high flood level to prevent burn from erosion due to ripple action. It is essential to identify the sources for the availability of construction material, especially clay and porous soil for earthworks and pitching stones for these slopes. What are the design criteria normally followed? Depending upon the average annual rainfall within the catchment, the yield at the proposed site of the percolation tank should have dependability shown in table 1, where the annual average rainfall is less than 380 mm. The percentage dependability is 40%. When it is between 380 to 760 mm, it is 50%. And when the annual average rainfall is 760 mm to 1520 mm, the percentage dependability is 65%. The earthen bunds, most important part of the tanks, as the percolation tank intends to raise the groundwater level of the area downstream of the site, water should be allowed to percolate below the seat of the dam. Therefore, for bunds having height up to 4.6 meters, cutoff trench is not necessary, and keying and banding between the dam seat and natural ground will be sufficient. For bunds having more than 4.6 meter height, cutoff trench equal to 1/2 to 1/3 of the water column that can be provided. The top width of the bund should be provided based on the height of the bund. Up to 3 meters, the top width required is 1.8 meter, 3 to 6 meters, minimum 2.1 meter, and 6 to 15 meters, the minimum top width required is 2.4 meter. Design of tank bund. The tank bund for all practical purposes is a small size earthen dam, and its design and construction should be carried out in accordance with the principal application to earthen dams. The bunds of 3 kinds: type A, type B, type C. In case of type A, it is a homogeneous embankment type. Type B, zoned embankment type, and type C is the diaphragm type. The common type of bunds which are used in India are type A, which are homogeneous embankment type. The type B bund have the impervious score in the central part of the bund, while a diaphragm wall is constructed in the center of the bund as shown in this slide. The full supply level. Depending upon the basin of the tank, the capacity of the tank is fixed to store almost all the yield expected. A freeboard of 1.8 meter should be provided above the HFL of the tank. Arting and casing zone may be provided as per the standards adopted in minor irrigation tanks. For the protection of the upstream slope against wave action, 225 mm thick rubble pitching should be provided. Downstream slope may be designed to have a minimum cover of 1.2 meters over the gradient line, drawn from HFL touching the upstream slope with a gradient of 4:1 in the casing zone and 2:1 in the halting zone. Now, after discussing the design requirements of percolation tanks, let us see that how these practices are followed, what are the issues, and what is the status of urban ponds. We'll see one by one the ponds which are situated in the city of Surat. As all of you know, Surat is one of the fastest growing city of India due to immigration from various parts of Gujarat and other states of India. Surat is the second largest clean city of India and also known by several names like the Silk City, the Diamond City, the Green City, and in near future it will be known as Electric Vehicle City apart from Bridge City of India. The oldest municipal corporation, 1852 AD, established in 1852 AD, having an area of 462.149 square kilometer. The population of Surat city is 46 lakhs 45,000 as per census 2011, and the current population may be around 60 lakhs. The density of population, that is 10,052 person per square kilometer as per census 2011. The land use land cover pattern of city of Surat, studied by Sridhar M and Rangarajan in 1999 to 2019, you will find that urban area has increased in terms of more than 175%. You will see 1999, 59.9157, that is the urban area, while in 2090 it has gone to 164. The water bodies, which was 29.709, that has reduced to 17.67 kilometers square. There is overall 0.812 square kilometer of shallow water bodies have been reduced during the period of 2011 to 2019. The cultivated land, that is reduced from 239 to 31 square kilometer. The vegetation, that has been reduced from 228 to 95 square kilometer in 2019. The barren land 148, that has gone down to 197, that has been increased 197 in 2019. The total area which they have studied is 706.875 square kilometer, which includes the peripheral area around the city of Surat. This is the first leg when we have talked about what should be the leg, how it should be designed. This is the example of it, that this pond, which is Pal Lake in Pal, Surat region, never get filled since last 10 years. No water retention storage in the lake immediately after monsoon season. What is the design principle? The design principle, as we have seen, we have to study the rainfall pattern, rainfall intensity. At the same time, we have to check, we have to ensure that water retention capacity of pond by carrying out geotechnical investigations. We'll see in the next slide why the water is not retained in the pond since last many years. The second issue is, you will see here, the urbanization. This is the slide which is important from study of urban ponds. In 1985, you will see on the right hand side of the pond as well as that of the left hand side of the pond, growth of urbanization. If you'll see, this is the 2000, the urbanization on either side of the pond. This is 2004. Slowly the urbanization has increased. The circle, black circle which is shown here, the urbanization has come up. The societies, apartments have come up on the right side of the pond. This is the 2022. And in 2022, you will see that almost around the pond, number of new societies have come up. And as this number of new societies, apartments, high-rise buildings, roads that have come up, because of that, what happened? We'll see in the next slide. So you will see here, this is the levels around pond. And you will see that all the area which is adjoining to Pal Pond, you will find that the value of reduced levels are higher, while that the level of pond become lower. Because of that, what has happened, that the rainfall water before 85, which used to flow, that is a watershed for this Pal Lake, all the natural streams draining into this wall has been blocked by this urbanization. And due to which, even though there is a 1200 mm rainfall in the city of Surat, average annual rainfall in the city of Surat, this lake is not get filled up. So level around ponds are higher than the pond. Therefore, it is said that carry out topography survey. That we have seen that the topography survey can be carried out using TopoSeed. Topography survey can be carried out. Now, recently the people are using drone surveys. And using the drone surveys, you can identify and check properly the site and find out and check the watershed area which will contribute or which will drain water to the pond. Due to urbanization, this is happening with almost every city, where the natural draining of water into the pond has reduced to a great extent. And because of that, the urban ponds have very less water compared to its capacity. Again, you will see here the another picture in which the watershed wise, sub-catchment wise, in the center you can see it is a Pal Lake, right? The rain gauge station is over here. Sub-catchment 1, sub-catchment 2, sub-catchment 3, and sub-catchment 4. So these are the catchments from which the water used to drain into the Pal Lake, which has been blocked due to the urbanization, and very less water drained into this urban pond. When it comes to the retention of water, how to check it? The investigation for the bed of the pond has been made by constructing a bore and trying to identify the geological formation below the bed of the pond. And it has been found that the bed has absolutely fine with storage of water. However, due to less inflow into the pond, the pond is not get filled up, and the water is not retained for throughout the year. However, when you are designing a pond, you should keep in mind evaporation losses, seepage losses, and depending upon the losses which are taking place from the pond, either you have to go for deep pond or that of the shallow pond. Rainwater collection chambers, you can see here the rainwater collection chamber is higher than that of the adjoining areas, and which will not drain the water or runoff produced in the adjoining area by the rainwater chamber, and it will not allow the water to get infiltrate into the water to flow into the pond. So chambers be placed referring to contour map of the area, and they should be placed at such a point where you can find that it can catch maximum amount of water which can be drained into the pond. This is another issue, that rainwater collection opening area compared to the runoff generated from this area, the opening area, the holes which are on the top of this chamber, they are less, which will result into the ponding of water. Hence, you are required to design the opening for chamber in such a way, or you may increase number of the chambers which can catch the water, and that water can drain into the lake. The gully formation, the pond has been constructed. It is not lined. You can see from this picture, it is with the earthen slope. And as this is the earthen slope, in case of heavy rainfall, this gully formation takes place, which will lead to, you can see that there is a wall, and it may lead into the failure of this particular wall, ultimately leading to the failure of the slope. So proper drainage arrangements be made in and around the pond. This is another picture of slope failure. The embankment must be designed in accordance with IS code 12169, so that you can avoid the failure of the slope. When it comes to the slope of the pond, what practice is followed for other ponds in Surat? And for that, I have visited the Lakeview Pond, that is near SVNIT college campus, near my campus. And in this pond, the situation was same as that of the Pal Lake earlier. Just 2 years back, they have rejuvenated this pond. And in that case, they have gone for vertical wall that has been supported by the gabions. The width of the gabions, you will see approximately 45 centimeter, and the height of this gabions is approximately 4 meter. So this prevents the retaining wall from failure, as well as it protects it from seeping of the water, seepage water. How it protects the seepage water, that we will see. So slope failure, design principle, provide appropriate slope protection. In this case, gabion wall is constructed around periphery of the pond. If you will take seepage, issue of seepage, though the water is, the pond, urban ponds are constructed, but retaining water in the urban ponds is again an issue. So when this pond is regenerated, you can see here on the backside of the gabion wall and between the retaining wall, a geosynthetic material has been placed. And that's this geosynthetic material that prevent the water loss from the sides of the pond. So laying of geosynthetic material to prevent losses wherever required, wherever necessary, that can be done for the pond to keep the storage of water for a longer time period. You can see here there is a pipe on the opposite wall. A black circle is marked and there a pipe is provided. This pipe is provided for two purposes. Number one, when there is overflowing of storm water, it will, the overflow water through this pipe drain into the pond. Here the question is that whether, why not this particular inflow pipes, they are provided in such a way that it catches maximum runoff and fill the pond. In India, we have a problem of contamination, pollution, and that polluted water, when it enters into the pond, it will result into another problem. Providing of this pipe, it serves two purposes. Number one, when there is a overflow from storm drain, it will fill the pond. And when there is flood, or when the pond is full, the water may flow back from this pipe, which will work as outflow from the tank. So the function of this pipe is, in case of overflowing storm, it will fill the pond, and in case of full pond, it will act as draining out of the water from the pond. The second picture shows it is the same as that of the previous one, but in this the problem address is algal growth. You can see that the water is not crystal clear or clean. The reason for this is that strictly the nutrients which are added into this pond through one or other sources results into algae growth, and therefore strict prevent entry of nutrients in the pond that is required. Apart from that, arrangements for aeration of pond, that will also help up to certain extent, but main is the nutrients which are falling into which are draining into the pond. They are responsible for growth of alga, and they are required to be, what you can say, prevented entering into the natural pond. In India, many of the ponds are having this problem, and either the authority is not aware or they are not able to manage the draining of wastewater into the nearby ponds, and that makes such condition, such situation in urban ponds, which is commonly observed. The few references which I have referred for preparing of this particular presentation. After this, I'll show you one design of pond, proposed design of pond, in which the various parameters, how they have been considered and how the pond has been designed. So this is about the, again, is my slide visible?
Yes.
Hello?
Yes.
Okay. So this is about the proposed pond in SVNID campus. The institute campus is expanded over 250 acres of land with various facilities in addition to academics, residential like post office, bank, guest house, canteen, etc. This is the map of SVNID campus and the digital elevation map, as well as the contour map of the campus that has been studied. The total area of SVNID campus is around 10,11,750. The built up area is around 3,70,000. The total road area is around 77,150, and area under vegetation is 5,64,497. As we have seen, for designing a pond, you should have sufficient amount of runoff be generated. You need to assure that, and to assure that, we have collected the data of average annual rainfall. We have worked it out. Maximum rainfall 1,895 mm, minimum rainfall 714.782 mm, and average annual rainfall of 1,232 mm. The volume of water generated due to it, annual volume of water, the intensity of rainfall 60 mm per hour, average runoff coefficient for the campus is considered as 0.77, area in kilometer square 1.011. Using the rational formula proposed by the code, Q is equal to 10 CIA, the amount of runoff generated from the campus, that has been worked out as 17,53,874. As we have seen, the dependability level that depends upon amount of average annual rainfall. The average annual rainfall is 1,895 mm. That has been considered here. The 65% dependable annual runoff comes out to be 11,40,080. So the runoff computation for the campus, that has been worked out considering number one, average annual rainfall, number two, intensity of rainfall, number three, average coefficient, runoff coefficient. As you know that it's a built the ARMA, the LULC pattern of the campus is having the hostels, buildings, etc. with green cover. So 0.77 coefficient is to be considered, and based on that, amount of runoff of volume that has been worked out. After working out the amount of volume of water available for proposed pond, next is to find it out soil characteristics. And for soil characteristics, two borehole tests become, and these borehole test results, you can see here, these are the borehole test results with the depth, and with different depth 1.5 meter to that of 13.5 meter. What is the type of soil? So up to 1.5 to 4, it is black color clay with high plasticity. 4.5 to 7.5 or 4.5 to 9 meter, brownish color clay with medium plasticity, and 10.5 to 13.5 yellowish color non-plasticity soil that has been identified. And based on this identification, it has been found that the pond can be constructed up to 1.5 to 3 meter depth or 1.5 to 4 meter depth. At the same time, in this proposed pond, recharge shafts are also planned to be constructed or to be provided. So what should be the depth of those recharge shafts? So for that purpose, these 4.5 to 9 wherein brownish color clay with medium plasticity is available, that is found suitable. Hence, if in the proposed recharge pond, if we construct recharge shaft up to the depth of 7.5 meter, it is sufficient to drain water into the recharge the groundwater. So that has been identified from the which test? That is bore test. That is borewell number 1, the test which has been carried out, and the data has been collected from this. This helped to fix number 1. Yes, it is possible to construct pond in SVNID campus. Number 2, depth can be taken as 3 to 4 meter. Number 3, the depth of recharge shaft can be kept between 7.5 to 9 meters. So this is again the further analysis of what is the type of the soil, that is CH, that is the IS classification of soils, and all the soils which are having classification CH, CI, they are considered to be good soil as far as the infiltration is concerned, as far as the holding capacity of the soil is concerned. So the decision was to construct a pond in this SVNID campus that is with the depth up to 3 meter and the recharge shaft depth up to 7.5 meter based on this soil investigations. From this already I have said, right? The storage capacity. Storage capacity of percolation pond is defined as the volume of water stored in the tank up to the full tank level. The storage capacity can be computed using the contour plan of the water spread area of the tank. The total capacity of the tank will be the sum of the capacities between successive contours. This storage capacity has been worked out. The smaller the contour interval, the more accurate the capacity computation be. The summation of all the volumes between successive contours will be required for computing the storage capacity of the tank. When a contour plan is not available and only the area of the tank at full tank level is known, and the effective volume of the tank may be roughly computed as the area multiplied by 1/3 of the depth from full tank level to the deep bed of the tank. The tank is designed to ensure maximum utilization of its capacity. A structure of optimum capacity is most cost effective. An underutilized structure leads to unproductive expenditure incurred on extra earthwork. So somebody will say, sir, why to go for 3 meter depth? Why you are not going for 4 meter depth? So these are the points which one has to keep in mind. Even if you want to increase the height of the pond by 30 centimeter, that is by 1 feet, it will incur lakhs of rupees of cost. So the volume of the tank or capacity of the tank need to be worked out in an optimum manner, which become most cost effective. From the contour maps and digital elevation model, the low-lying area of the SVNID campus is identified. The area available for constructing a proposed area is 40,000 square meters. The depth of groundwater table at the proposed location is observed as 9.13 meter. This is a very important point. The depth of water table. If the water table is very close to the ground, I do not know you have a mic in the hall or not. If you have a mic, you can interact with me. If the depth of the water table is very close to groundwater, that very close to ground, what will happen? Can anybody reply? Sir? Yes, I am not able to hear any one of you.
The ponding will occur because water table is
Ponding will occur, right? Therefore, see, this is very important for as an engineer for us, that whenever somebody comes to you and ask that, sir, we wanted to go for recharge structure or we wanted to do the rainwater harvesting, right? You should check engineering in a scientific way whether it is possible
Water
to
logging.
construct a whether it is possible to construct a pond there or not. Sometime back I got a call from IIT Jodhpur, and the dean planning and development wanted to construct a pond, recharge pond, into IIT Jodhpur campus. I asked him, you please share me the borehole details, that is geological investigation, which are carried out in your campus. Initially he refused that we do not have any geological investigations. Then I asked that, sir, yours is a new IIT. I am very much sure that before constructing buildings, someone has gone for geological investigation of it. And he sent me those geological investigation, and I found that just 30 feet depth, 30 centimeters, that is 1 feet, approximately 1 feet to 2 feet depth, there was a hard rock. And if it is a hard rock, you can understand, even if I am saying that you go for a pond of capacity of 50,000 liters, it will be a costly affair. That is number one. Number two, the retention of water in the pond, it itself is a problem. Because if I will say that you go for a shallow pond, it will go for evaporation. Because IIT Jodhpur, sir, probably you may be knowing, it's in Rajasthan, which is a very which have a high temperature during monsoon season and probably have a higher evaporation rate. So I cannot ask him to go for shallow pond. I have to propose him, I have to advise him as a consultant to go for deep pond. But if I am saying that you go for a deep pond, at 30 to 60 centimeter depth, there is a hard rock. Imagine what will be the cost of construction of even 2-meter depth of the pond there. So such type of a practical problems one faces when he is practicing in the field. However, if you have got funds, it is possible to construct, depending upon that the rock formation you have to check. It should be fractured rock, highly weathered and fractured rock. At the same time, that should not be again localized. It should be sprayed over the entire area so that the percolation inside, right, that should happen if he wants to go for the recharging of it. But somebody will say me, sir, in Rajasthan, why he is going for a recharging? Yeah, it is possible to go for recharging, but there the purpose is that for non-monsoon period, they wanted to create a storage, and there you can use geosynthetic material to be sprayed over the bed of the pond, where you can do the storage of water. To me, I have a area that is Hazira industrial area, and there the water table is very high, just close to the ground, and these industry need fresh water in terms of lakhs of liters per day, and they have constructed ponds, storage ponds, 1 kilometer by 500 meter, not one number of ponds, and they pump surface water of Tapi river approximately 10 kilometers away from this industry, which is called as Singanpur Weir, and from there the water is supplied from the Singanpur Weir, that is 10 kilometers away, to fill these ponds. And you will not ready to believe the cost of pumping per month is in terms of lakhs of rupees. That is the cost which they incur to just have fresh water to run their industries. Coming back to the water table depth, that is 9.13 meter, which will, from which we have worked out the capacity of pond 200 into 200 into 3 meter depth, that is 1,20,000 meter cube. The design of pond opted for type A as per IS 12169 criteria for design of small embankment dam. Type A embankment is to be considered with slope of upstream and downstream fresh 1.5:1 and 2:1, the stone apron or riprap. The code of practice followed to check the stability of earthen dam, that is IS 7894/1975, that has been followed to check the stability of upstream slope, downstream slope of the pond. The IS code 8237 code of practice for protection of slope of reservoir embankment that has been followed for stone apron or riprap. The width of the one is kept 1.5 meter, the freeboard is kept 1.2 meter, and the recharge shaft, as I said, that whenever there is a full reservoir, full pond level, the water will spill into the recharge shaft, and the depth of the recharge shaft is kept as 7.5 meter, as well as the recharge shaft pipe is equal to the full reservoir of pond, but 50 mm less than the top of overflowing weir. So we have proposed the weir also, which allows the water to spill out from the pond. This is another issue in India. Over the period of time, what has happened that whenever the tank overflows, there may be a small stream which will be carrying water to the nearby water body or nearby river. And you will find that all around the pond, there is a encroachment or the unpaved areas. So in monsoon season, when the pond becomes full or it overflows, the adjoining areas get flooded. Probably some of you might have read in the newspaper or listen on the TV news that so and so area get flooded because of what we can say overflowing of a pond. This has happened in case of 2022 Pakistan floods. There, the one of the pond which has overflooded or overflowing, and that has resulted into the inundation of square kilometer of lands. You can see the pictures of it. If you will search on the internet, you will find those pictures, even the videos of those regions. Probably still the water is not completely drained out of those areas. So when the release, not only the provision of hydraulic structure or provision of overflowing water to pass from the dam, but at the same time the drainage, the stream which carries this overflow water from the pond, that should be kept free so that water can be taken from the overflowing pond to that of the nearby structure. So this is a design of wastewater with that is a surplus weir that has been designed, and the difference between FTL and maximum water level is proposed as that of the 0.5 meter. This is the plan and section of the proposed plant, SVNIT plant, which is shown over here. I'll show you the section and where the recharge valve, you can see in the center of this, the recharge valve is constructed, and when the water level rises, not up to the overtopping, but beyond certain value, what a certain level, what will happen? The water will start overflowing from the pot. So this is proposed depth of recharge well, as we have identified from the geological investigation, that is 7.5 meter, that has been provided over here. After discussing the proposed pond, which has been planned to construct in SVNIT, we will take you a very interesting case. The next is very interesting, and all of you will definitely like that. This type of measures are required to be carried out all over the country, where you find that there is the pond which is known as Gopi Talav, and the Gopi Talav is also a very famous pond, the historic lake of Gopi Talav, which was date back to 17th century and was a very important urban space for the trading city of Surat. This lake lost importance due to negligence 19th and 20th century both. You can see that more than 200 years. This pond has lost its importance more than 200 years. And it has become health and social menace. How? We'll see it in the next slide. Yes. You can see here, 1 minute, this is images. Hello, everyone can see? One is on the top. one is on the top. And you can see that these all small around the pond, even inside the pond, these are all small huts which were enclosed by the poor people. And the huts were constructed inside the pond. The major problem of regenerating this pond is to shift these people. What Surat Municipal Corporation did? You know that there is a scheme for EWS, economically weaker section people. And these people in phase wise, this population was so huge that in phase wise, they have given flats in the EWS schemes and removed this all encroachment all around the pond. So this is the image before the regeneration, that is 2015. This is the image in 2022. You can see the pond below, which is a regenerated pond in 2022. And every day, number of people are visiting this particular pond. Let us see the details of it. So this is 10-2000. You can see the slums are there inside the pond. This is 10-22, wherein you can see the pond is regenerated. The project site is located in the heart of the city of Surat. The area measuring 10 hectares, approximately 1 lakh square kilometers. So now you can understand what I said, that thousands of people are required to be shifted from this region to EWS region. That was a Herculean task which has been carried out by Surat Municipal Corporation successfully, right? The original water body which was lost in the process of city growth and urbanization is regenerated as a lake and public park. How it is done? Let's see. So the project is divided into 7 zones, excluding that of the water body. These are the area statement. You can see the water body 34,250 square meters. History zone. History zone means what? In this particular zone, the history of pond, history of city of Surat, that has been created, that has been placed. That is 4,220. Environmental zone 5,310 square meter. Diamond zone 5,215 square meters. Food courts, they are 5,880. Textile zone 5,290. Communal harmony zone 6,161. And for future expansion, approximately 10,000 square meter of land has been reserved. The plot area is 82,963. The area of land 34,254. See the area of walkway, it is 2,317. Why? The road area is 13,680. The landscape area is 35,150. The platform, decks, etc., amphitheater, that has been planned in 2,528 square meters. The project technology, the major challenge, the major structural challenge was creation of the water body in backfilled land. Not only that, to prevent contamination of the water to be stored in the reservoir, it was important to create an impervious site. And for that purpose, what has then been done? For this purpose, a 7-meter high retaining wall was constructed bearing a base width 2. All around the pond, a 7-meter high retaining wall has been constructed to retain the water in the pond. So this you see from the bottom, I think it is visible that bottom is backfilled lake. So what they did, excavation done for water body. Then next is RCC retaining wall for contaminant of water body to prevent it from contaminants of water body. Then construction of various structures like guards, then submersible platforms, viewing deck, etc. So you can see that this is the what you can say, the platform, while guards are there as well as viewing decks are there. Then introduction of inner ring and outer ring within internal roads. So one more ring is added around it, right? And 7 thematic zones depicting the peculiarities of Surat that has been added into this. So 1, 2, 3, 4, 5, 6, and 7 zones. So these 7 parts you can see now, they are the 7 zones which are used for food courts, which are used for historical demonstration of history. They are used for the environment purpose and for the future development. This area has been developed, which you have seen that wherein in 2011 the encroachment was there, fully it is encroached, right, which has been removed, and such a beautiful lake has been what we can say created. So total project area 10 hectares, area of water body 3.30 hectares, area of 7 zones 4.50 hectares, and roads and miscellaneous 1.20 hectares. So this area statement, because if you have seen the 2011 picture, that is Google image, and then you see this particular area, you will definitely realize that which way this development has been carried out. These are the brief history or small history about the Gopi Talab, which has been rejuvenated in 2015, started in rejuvenating in 2015. It is a very old 1510 AD. Probably you may be knowing the Surat is the city where the Britishers come first, and they have established their koti in Surat. And even the ships used to come up to Chowk Bazaar. Now it is silted. That path is completely silted, and even the ships stays away from the seashore, approximately 4 to 5 kilometers inside the Arabian Sea. That much of silting has happened. But this is the era in 1510 AD. The big ships used to come up to that of the Chowk Bazaar, that is heart of the city, center of the city. Such a glorious history the Surat city was having. And Gopi Talab, that is specifically built for what we can say local water requirement, to supply the water to the people during non-monsoon period. This specific pond was constructed during that period. So these are the pictures of different ghats. That is Gopi Ghat, you can see here. This is another picture. Now you see that retaining wall. You can see at the same time the area which I have told you that it has been developed, right, where you can see the boating is also there. The platform is also constructed. Ghats are also this is the another view of the pond. Here you can see that retaining walls which are constructed on all sides of the wall, all sides of the pond. The lush green area, which you cannot which one cannot imagine, because I am in Surat and I have seen the this place before rejuvenation and after rejuvenation. It is like a dream come true that such type of greenery is possible specifically at this location. So these are all various zones. As I said, textile zone, they have given the name textile zone, doesn't mean it's for textile zone. The Surat is famous for textile, diamond, green cover, etc. So various spaces they have given this name. Specifically, this textile zone is meant for children play area. Diamond zone is meant for water fountain, that is environmental area. Dhobi Ghat, the Gopi Ghat, that is a ghat for taking bath and all that. It is of course not allowed nowadays. Then this is what we call it as a food court zone, right? It is there is a proverb where it is said that Surat nu Jaman and Kashi nu Maran. That means the food of Surat and death at Kashi is considered to be very auspicious in Hindu dharma, and accordingly this here it is written as Surat nu Jaman. The food court is named as that of Surat nu Jaman zone, which is one of the which is from the very famous proverb used for Surat nu Jaman and Kashi nu Maran, right? This is a step way, right? This step well is also rejuvenated. This is along with the Gopi Talab, and the clear picture, neatness, cleanness, you can see that this is the one which is also rejuvenated along with that of the Gopi Talab. This is again the bird view of the Talab. Just you can see what was it which we have seen in case of 2011, the picture which we have seen, Google image which we have seen. And sir, this is the urban pond rejuvenated by Surat Municipal Corporation. incorporating all engineering aspects and facing challenges right from shifting of people to land acquisition. So this is a great example. I love it to show it to you. And at any time, any of the participant is in Surat, definitely keep this particular place in your list that you will definitely feel happy after visiting this place. So thank you very much for this first lecture, Urban Ponds, and that is Principles and Practice. Thank you.
What's the source of water to this pond?
Maybe the storm water coming from the other area. That's my understanding.
Any
Pardon me,
questions?
sir.
Yes, you can.
Sir, so thank you, sir, for the nice lecture. After 15 minutes, you can meet. Tea break. Hello?
Yes, sir.
After tea break, you can meet after 15 minutes.
Okay, 10 to 15 minutes, sir. 15 minutes, fine.
Okay, sir. Okay, fine, sir.
Okay.
Professor Yadav,
I'm not disconnecting. I'm keeping my connection live. Okay.
Yes.
Professor
Meanwhile,
Yadav,
any participant have any question, they can ask me.
you can ask.
Yes, sir. Excuse me, I have a question, sir. So what is the source of
Yeah,
water to
please,
this Gopi Talab?
Yes, that is a very important question which you have asked, right? Because you've seen all around it is a urbanization. And
Right, sir.
because of urbanization, it is not possible to fill this pond with natural water, natural rainfall or natural drains. And therefore, the Tapi River, which is approximately 2 to 3 kilometers away from this particular pond, they fill this pond with the surface water, that is of river water of Tapi.
Okay.
So that
So-
is pumping.
Pumping systems. As of now, it is a stagnant water, right, sir?
And pardon me?
It is a stagnant water, no? There is no source of
No, sir.
circulation.
No, they are actually they are pumping water inside the pond every alternate day or every 3 days, right? At the same time, there are fountains, number of fountains installed into the
Okay.
pond, and because of that, the water keeps what you
Aeration.
can say circulating. Yeah,
Yeah.
aeration is there. Yes.
Thank you, sir.
Okay. Any other question than this?
Sir.
Yes,
how
please.
This pond will be helpful for controlling pollution. Like if there is a developed city, like Surat, if I talk about, then there are many textile industries are there which are creating effluent from their source. So sir, that is also coming there. So in case if there is any developed cities there and I want to construct this pond, then how it will be helpful for controlling pollution? Can you
Sir, pollution itself is a big challenge for all water resources, and it is very, very difficult, right? Unless and otherwise you have taken proper measures, then only you can control the pollution to enter into the water bodies. The pond which I have shown you, that is Piplod Lake, where you have seen the growth of algae, right? So to find out from where the nutrients enter into the pond itself is a task which required to be taken care of. Any other question?
No, sir.
Okay. Thank you. We'll meet again after 10 minutes.
Okay.